AI and open compute. AI is a hot topic right now.
I think I'm hot.
It can solve the world's hard problems, but it can't do it by itself. It needs decentralized open compute. So let me explain a little bit about what that means. First, what are the biggest problems? They're the ones that are most complex, right? Climate, monetary policy, energy, disease, these are relatively an obvious list. So how are we doing in solving these problems as a race? Every climate forecast has been wrong massively. The US Federal Reserve, with thousands of employees and tons of PhDs, can't figure out when to raise rates, certainly gets it wrong. We have all kinds of data points on health that we can't use. Genome is sequenced, but we're not allowed to compare it to phenotypes, so we are, a lot of terrific innovation is latent and sitting there unused. There are all kinds of clean energy options, but countries like Germany are increasing coal, and the pandemic modeling was wildly off. Right? So there's a lot better we can do in all these problems. So, and why are they hard? They're hard because they take a lot of compute power, price matters, the location of the data matters, and it helps to be on the edge. But the biggest problem is relationships are not stable over time. They're always evolving. And so you need a solution that doesn't analyze data in a static way, but keeps evolving and keeps innovating because the problems change. Looking at something can change it. Certainly true with monetary policy, and as we all know, diseases evolve as well. So AI to the rescue, right? AI can solve this. LLMs can dig into huge and incomplete data sets to pull out inferences that traditional programming cannot uncover and won't uncover. And that sounds like, and could be, a terrific solution, and for many things it is. But AI isn't perfect. It's not verifiable, right? You don't know for sure what data your model was run on, and you can't verify it. It's certainly subject to censorship. I think people here are very aware of the discussion and topics around answers, and particular answers that can't be answered the right way, and questions and how they're addressed, and what data even goes in. Data refresh. You have to constantly be refreshing the data in order for it to be relevant. And also, AI itself is going to continue to innovate. So even if you're refreshing the data, you've got to keep changing your model to make sure your model is evolving and is the latest and greatest option for evaluating that data. So open compute and compute solutions have evolved to try to solve some of these problems. And people have been working on compute solutions for years, but none have worked. And there's a whole number of reasons why compute hasn't worked in a scaled, seamless manner. But there have been coin economy flaws, clunky user interfaces, poor architecture decisions, and also very little true compute decentralization. The exception of that is the smart contracts. Obviously, smart contracts are truly decentralized, but they don't have the scale for compute. And that's why compute is hard. That's why open decentralized compute is very hard, because you have to be generalized, verifiable, and scalable. And while smart contracts are verifiable, they are not scalable. And we can talk as much as we want about layer 2s, about extra sharding solutions, but generalized compute is hundreds of orders of magnitude more demanding than the most optimistic projections of actual smart contracts. So we need a different solution. And so you have to build decentralized and verifiable without blockchain. And that is difficult. And so we go back to decentralization. And if everybody here remembers, I'm going to reference the next speaker is from Napster. Right? Napster is the first application that was decentralized at scale. Way predated blockchain. So there's ways to do decentralization pre-Bitcoin, pre this universe. And so what that is, I think, if you look back, we actually can get a better solution to these problems. And so Fluence, which I'll talk about in a moment, isn't bound by these blockchain constraints and can run any type of computation. And so how does open decentralized compute work? It's got limitless scale, and it's unstoppable. You got large capacity, thanks to crypto incentives. It's enterprise grade. Enterprise grade data centers aren't going to rely just on coin economy. They need fiat payments. They need to know that their expenses are going to be covered with a high degree of certainty. So you can't just do a crypto economy and expect to have a durable, enduring, scaled, enterprise-grade system. You have to be, it's edge-enabled, and it's verifiable. We have a proof of compute, so you can actually validate that the computation has happened. And with subnets and fault tolerance, you have true decentralization. User interface, follow the well-known user interfaces, and so it's familiar to developers, best in class. And so what does that mean? You get open compute decentralized benefits that you get verifiability. You can verify that the compute was run on particular data. It's also censorship resistant because any host can run applications. If a host goes down, your application shifts and the compute shifts to another host. Super, super important. It's cheap because when you basically can shift from host to host, the compute can move from provider to provider, there's no pricing power. And with no pricing power, there are very thin margins. And with thin margins, you see the customer saves money. And so you end up with very inexpensive compute, potentially 80% cheaper than centralized cloud versions. And it's buildable. And this is, I think, the most kind of interesting part. And this is the part where it ties back into AI, where applications and data can be hosted, and as long as there's demand, that data, those applications are hosted, which gives people and developers the ability to build further on top of that data. And they can keep building and know that they cannot be turned off. And so that leads to applications that aren't stoppable. And so let's think about innovation for a second. Every company has a product roadmap of features, right? But that roadmap has to be constrained. It's constrained by the team, by the skills, by the budget, by priorities, by internal politics. Pick your company, pick your Google, pick your Facebook. They still can't do everything at once all the time. They have to prioritize. And so what is more powerful than those companies? The global developer community. And so when you have applications and data that's open and buildable, the whole world can be out there working to innovate and build on top of those applications in a basically limitless product development role. And you say, that sounds great, does it work? Well, it actually works so well that we have proof the biggest companies in the world can't compete. Facebook, Twitter, and Reddit all had open APIs, but the developer community globally kept coming up with applications that were so good, it was drawing users away from those core applications. And so those companies, largest in the world, shut off those APIs because they wanted to control the data and users themselves and didn't want things sucked away. They effectively used the developer community as a product development testing ground, found stuff that worked, and then shut them off. But what does that mean? It meant that that's the level that innovation got to. So they've continued to innovate, but we have no idea what else could have been built if those APIs had stayed open and more, and we'd been a decade later with what's happened. And so what does open computation enable? No closed ecosystems. You can build on top of applications if you want. That we think is a creativity accelerant. You basically get a transparent cloud with vast offerings. And leads to unstoppable applications, where applications can't be turned off, can't be censored, can keep running, and can continually be built on. And that's why we think that decentralized serverless compute is the next generation of internet computing. We started off with mainframes and desktops 1.0, kicking and screaming over 20 years, moved over to the cloud. That has been a resounding success. Whereas that transition still continues. But decentralized serverless compute is certainly the next, if not the last stage, where applications exist free of centralized companies, free of centralized ecosystems, free of single points of failure. That is what Fluence enables. And so what is Fluence? It's the decentralized serverless compute platform. It replicates cloud services and adds decentralization benefits. So you can build and scale applications easily with off-chain compute. Importantly, we've replicated the cloud stack so that you can build native peer-to-peer, native decentralized applications, which we know people use the cloud for a reason. It's easy. The stack is simple and it is easy to build. That's why it works, right? So the only way we can compete is if we have built a stack that mimics that, but works for decentralized applications. Back to AI, that allows you to run AI models cheaply, censorship resistant, and with the ability to compose on top of them easily and innovate on top of those models and continually innovate those models. There's something like, I think Hugging Face, I just heard, has 340,000 models on it, and they're adding around 40,000 a month, all right? And to give you a sense, ChatGPT costs about $700,000 a day to run. So if you want to run a model and you think you're going to have users, you're not anywhere near ChatGPT, a tenth of it. That's super expensive if you want to run it on centralized cloud. Your only shot is to run it in a system where you've got an 80% price savings. And you also want to be able to innovate and build on top of existing models. So that is the tie-in between open compute, which saves you money and allows innovation, and AI. And together, you really have something that's very powerful. And so the product that Fluence has is this decentralized Amazon Lambda. That market, the serverless market, is 9 billion today, growing to 55 billion, and that is an enormous market, which is what we think we can grow even beyond that. And so take a step back and imagine what it looks like when you've commoditized the back-end services. You've got unstoppable applications. All the effort of development can be spent on user interface, on innovation of things that matter, not the back-end services that people continually have to rebuild. The global community, developer community, is constantly looking for how to find better products, how to innovate. And when you have a default open ecosystem, that innovation is rewarded and can continually evolve. And so we think we enable a constant, transparent, and relentless innovation. And that, we won't solve all the problems immediately, but with both AI and open compute, we can do a lot better than we have. So what's our mission? We want to empower the next wave of internet innovation. And going right back to the founder of the internet, Tim Berners-Lee, his goal, the goal of the web was to serve humanity. He didn't know exactly what the HTTP protocol would and what hyperlinks would allow, but he knew it would be big. And he couldn't imagine it, but he knew there were things out there that would be terrific. And it's been an incredible boon to humanity. That's the type of thing we think open compute, especially with AI, can enable. So sign up, learn more about Fluence. Website is fluence.network. Get this QR code, join our Twitter and Telegram channels, and stay in touch. We're going for mainnet by the end of this year. Let's say winter, and so we're very close. And everyone's cheering, so thank you. Appreciate it.